Okay, now that we've got the theory down, or the idea down, let's do some examples. For the first example, I want to look at x prime equals minus 2x minus 14e to the 5t. The homogeneous problem is x prime equals minus 2x. And so from there, we get the homogeneous solution. It's going to be x sub h is c1 e to the minus 2t. The forcing function is minus 14 e to the 5t. And so our guess then is going to be an exponential with the same exponential number, the e to the 5t. So I'm going to guess an a naught e to the 5t. And now I'm going to stick this into the ODE. And so the derivative is going to be 5a naught e to the 5t. That's my derivative. Is going to equal to minus 2 times my guess. And then I have the forcing function, which is minus 14 e to the 5t. I notice that all the terms have the e to the 5t, so I can cancel them out. And so when I do that, I have an algebraic system left. When I add it over, I have 5a naught is equal to minus 2a naught minus 14. So 7a naught equals minus 14. So a naught is minus 2. So in this example then, the particular solution is minus 2 e to the 5t. And the general solution is the sum of the homogeneous in particular. So we get c1 e to the minus 2t minus 2 e to the 5t. So the problem's solved. That seems a little bit easier than variation of parameters. Not a whole lot in this case, but you know, it's something, and it's certainly a quick and easy way to do things. For our next example, we're looking at x prime equals 3x plus 5 minus 6t. So in this case, the homogeneous is x prime is equal to 3x. And so the homogeneous solution is given by c1 e to the 3t. Now here we have a linear function for our f of t. It's 5 minus 6t. So we're going to guess a linear function. So we'll guess xp is equal to a naught plus a1 times t. So we have two constants to find, an a naught and an a1, so we'll need two equations. Okay, so we do the same thing. We plug it into the ODE and let the ODE tell us what it's going to do. So the derivative of this is just going to be a1. And so that's going to equal to 3 times our guess. And then we have the forcing plus 5 minus 6t. Okay, the next step is what I'm going to do is I'm going to group everything together. I'm going to group all the constants together and all the t terms together. And when I do that, we get 3a naught plus 5, or 3a naught. I bring everything over to the right and group. So I get 0 is equal to 3a naught minus a1 plus 5. And then I group all the t terms together, and I get 3a1 minus 6 times t. Okay, so here's an equation, but the ODE's gone now. Now I'm just saying there's a polynomial, a number plus another number times t. And this has to be 0, and it has to be 0 for all values of t. And since it has to be 0 for all values of t, the only way that can happen is if the coefficients are 0. So we get The first coefficient is equal to 0. So 3a0 minus a1 has to equal to minus 5. And the second coefficient equals 0. So we have to get 3a1 is equal to 6. Look at that. That's a nice algebraic system of equations. Linear systems, what we've been doing for the first part of the semester. This one's easy to solve. Second equation tells me a1 is equal to 2. I plug it into the first equation, and we get 3a0 minus 2 is minus 5. And so that tells us then that a0 is minus 1. And so our particular solution then is going to be equal to minus 1 plus 2t. And so our full solution is going to be c1 e to the 3t minus 1 plus 2t.